Introduction. Anything that has mass and volume is matter. Matter is also defined as anything with the property of inertia. Objectives. At the end of this lesson, you'll be able to understand the difference between elements, compounds, and mixtures, know about the properties of solution, understand the difference between suspension and colloidal solution, understand the concept of separating two miscible and two immiscible liquids, classification of matter. Substance. A substance is a material with a constant composition. This means that the substance is the same no matter where it is found. NaCl, H2O, Ne, CO2, and O2 are all substances because their composition will be the same no matter where you find them. All elements and all compounds are defined as substances. Elements. Compounds and phase. Compounds. Compounds are substances that are made up of more than one type of atom. Water, for example, is made up of hydrogen and oxygen atoms. Carbon dioxide is made up of carbon and oxygen atoms. Table salt is made up of sodium and chlorine. Compounds differ from mixtures in that they are chemically combined. Unlike elements, compounds can be decomposed or broken down by simple chemical reactions. Phase. A phase is any region of a material that has its own set of properties. In a chocolate chip cookie, the dough and the chips have different properties. Therefore, they represent separate phases. Pure gold, which is an element, would only contain one phase. Italian dressing would clearly represent several phases, while a solution of salt water may only contain one phase. Homogeneous materials and mixtures. Homogeneous materials. Any material that contains only one phase would be considered homogeneous. Elements like hydrogen, compounds like sugar, and solutions like salt water are all considered homogeneous because they are uniform. Each region of a sample is identical to all other regions of the same sample. Mixtures. Mixtures are made up of solutions. Solutions are a special type of homogeneous material because unlike compounds, the parts of a solution are physically, not chemically combined. When you mix a glass of salt water, the salt does not chemically react with the water. The two parts just mix so well that the resultant solution is said to be uniform. Iced tea, coffee, metal alloys, and the air we breathe are some examples of solutions. Solutions are made up of two parts: the solute, which gets dissolved, and heterogeneous mixtures. Heterogeneous mixtures. Compounds. A compound is a pure substance made up of a chemical combination of two or more elements in a definite proportion. A compound contains two or more kinds of atoms chemically combined together to form new molecules. Water is one such example of a pure substance. The compound, namely water, is formed by the combination of two elements, hydrogen and oxygen, in the proportion 1:8 by weight. Compounds are homogeneous materials which contain two or more elements combined in a definite proportion by weight. Examples of compounds are common salt, carbon dioxide, etc. Differences between elements and mixtures. When two or more elements or compounds are brought together, they mix together without losing their individual properties. These are called mixtures. A mixture may be defined as that containing two or more substances in varying compositions. Like air is a mixture of several gases. It contains elements such as oxygen, nitrogen, and compounds such as CO2 and water vapor. Activity. A mixture of iron and sulfur is taken in a dish. A magnet is brought near this mixture. What happens to the mixture? only the iron fillings get attracted to the magnet. Add carbon disulfide to the mixture. What do you notice? The sulfur particle dissolves while the iron fillings remain unaffected. What do you understand from this activity? We can understand that individual components of a mixture retain their original properties. Here, iron retains its property of getting attracted to a magnet, and sulfur retains its property of dissolving in carbon disulfide. Differences between compounds and mixtures. Activity. To study the difference between a mixture and a compound, take 56-gram iron fillings in a china dish. Mix 32 grams sulfur powder into it. Mix them thoroughly. In another china dish, take 56-gram iron fillings and 32 grams sulfur powder. Heat this dish to a high temperature. Now take a magnet. Pass it through both the dishes. Record your observations. Sublimation. Substances like ammonia chloride, naphthalene, camphor, etc. change directly from solid to gaseous state on heating. For these substances, sublimation technique is adopted. Sublimation is a process of conversion between the solid and the gaseous phases of matter. Activity. Take a mixture of sand and iodine in a china dish. Cover the dish with an inverted funnel. Heat the mixture gently with a burner. Violet fumes of iodine vapor can be seen to rise through the funnel. The iodine vapor condenses to a solid on the cooler surface of the stem of the funnel. Now stop the heating when no more vapor comes out of the mixture in the dish. The pure iodine crystals are scraped out. The non-sublimable sand remains in the dish. Iodine is a common example of a substance that visibly sublimates. Physical change. To understand the difference between a pure substance and a mixture, we should have the knowledge about physical and chemical change. Color, hardness, rigidity, fluidity, density, melting point, boiling point, etc. are the physical properties. Physical change. The interconversion of states is a physical change because these changes occur without a change in composition and no change in the chemical nature of the substance. For example, although ice, water, and water vapor all look different and display different physical properties, but they are chemical change. If there is a change in chemical nature of the substance, then it is called as chemical change. Example 1. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air, whereas water extinguishes fire. It is the chemical property of oil that makes it different from water. Example 2. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings change in the chemical properties of matter, and we get new substances. A chemical change is also called a chemical reaction. Let us summarize what we have learned. Matter is classified broadly as elements, compounds, and mixtures. Elements are substances that are made up of only one type of atoms. Compounds are substances that are made up of more than one type of atoms. Mixtures are made up of two or more substances that are physically combined. A solution is a homogeneous molecular dispersion of two or more substances. The liquid in which a substance is dissolved is called a solvent. Solutions are classified as unsaturated, saturated, and supersaturated solutions. Suspension is a heterogeneous mixture in which small particles of solid remain suspended throughout the mass of the liquid or gas without getting dissolved.